Okay, let's take a look at, the trigonometric review summary. So the first page of the review is top left, special triangles. Memorize those. How to use the ASTC graph and where all the arrows go. SOHCAHTOA, and a reminder to always inverse the positive. The unit circle and how that stuff relates. Graphing and the quadrants and how to find angles, but that's confusing. Logics can do much better for you. Down to the right, we have the sign law. If we have the opposite pair and one other piece of information, or the ambiguous case, ASS. And then we have the cosine law, where we use it if we have SAS, side angle side, or SSS. And then off to the left, we got the opposite pairs and rationalize the denominator, maybe. And down below, we have finding the general solution and the idea behind graphing sinusoidal functions. So further in the notes, what you can recognize may have changed by now, but sine of 300 is negative root 3 over 2. That may or may not be correct in the notes. Right now online it looks like 2 over root 3 positive, so that's really getting to me, but there's an error every couple chapters. I'm sorry. Okay, so proposing the original question again, sine 300 is what? Well, we've got an ASTC graph. We draw an angle of 300 where it belongs. 300, we make a terminal arm. We then label the side lengths according to special triangles and figure out what the sine ratio is. And we know because we're in the C quadrant, that's how I knew the answer was negative, and the answer is opposite over hypotenuse. So, again, it's just so far off. And one of my final things I know to do is check your answer. And I signed 300 on the calculator, and I didn't get what I had. Whichever. So, I mean, watch out for that. Be on top of things. All right, you're just as smart as I am. I just know how to do more things than you, whatever. Okay, so down below, the second type of example. Keeping in mind, the first type of example is just one answer. Now we have an equation where we do the same stuff and draw the ASTC graph and put the arrows in and figure out what those arrows are worth. And then we get two answers. Remember, it's a different special triangle. And notice I rationalize the denominator. So that thing off to the right, if it's difficult to recognize when to do that, well, go to chapter whichever radicals and practice rationalizing the denominator. You might not be able to recognize your special triangle. Okay, so top left, that's one type. Then we have the second type. And the third type where we just use the unit circle instead. And they might change up the domain on you, or whichever. And the fourth example down below, we have negative tan theta equals negative a quarter. Two triangles where tan's negative. Inverse it, get the reference angle, positive 14, put it there. And then now we have a domain from negative 180 to 360. So we have to consider all of our angles plus or minus 360 to get to all of the other angles. Great. So 3 main types of questions. Now, a little bit on the summary on the ambiguous case. We're always going to start off with an angle. Excuse me, that got so far in the way. So we are, again, always... so I'm losing a line each time. Okay, I'm just going to undo a few steps. There we go. Okay, so I'm going to draw that line in red again. We always draw an angle given the same way, starting here, going up this way. Then we're going to have a bunch of different cases. So, for example, if a side length given, represented as a line way over here, and we don't know how this is going to work, we want to think as the door hinge at the top, like we talked about in the notes. And this door can swing back and forth. Logically, if we find the height of the triangle off to the right and put the height in the diagram, And we know the height is exactly what we got doing SOHCAHTOA. And it's exactly that height, we get one triangle. Now, if this is longer than this, well, it can't do the swing arm thing. So the next example, if this is longer than this, again, one triangle. So we have two cases of one triangle. If, for example, this little itty bitty part on our little door hinge, it doesn't even make it down, isn't even as long as the height that we figured out above, 4, well, then it just doesn't make a triangle, 0 triangles. Then we have the interesting case where we have two potential triangles based on the same given information. If you draw this angle, and you draw exactly that angle twice, and then I tell you have a 6 to put in there, well, where does it go? Does it go here or here? Well, it goes in both. 6 or 6. 6 or 6. So it's ambiguous because we don't know which one it is. And then, so that's two options for triangles. And then we have the obtuse case down below, which is just two setups. Think about it. If we were to draw the angle like we usually do, 120, an obtuse triangle, an angle greater than 90. Well, if this arm is 6, if this is longer than 6, it'll make a triangle. So if this is 6 and this is 10, well, we'll get one triangle. But if this is 6 and this is 4, well, this thing doesn't even come down and make it. 0 triangles. So we have different cases, acute cases of 1, 0, and 2 triangles, and obtuse cases of 1 and 0 triangles. The big one in the center is the ambiguous case where we have two cases. The algebra is very difficult. Very carefully look through the notes.